We believe we've got a game changer in terms of greening the industry.
I think this has the realm to be in that scope of discussion, like uranium and potash coming from Saskatchewan. Yes, I certainly do.
Saskatchewan could be adding another game-changing industry to its natural resource portfolio. Long known as an agriculture, potash, and uranium stronghold, a new discovery could change Saskatchewan's perception.
Almost nobody cared about Tisdale, Saskatchewan, until miners found something huge under the ground. This hidden discovery could help Canada become one of the world's biggest aluminum powerhouses, bringing jobs, money, and control over a metal used in cars, planes, and clean energy. But for the United States, this is a warning sign. If Canada takes the lead, America could lose power over an industry it depends on every day. It is a small community in the east central part of the province, surrounded by agricultural land, unremarkable from the air, and invisible in the global conversations about industrial strategy, critical minerals, and the future of clean energy supply chains. Until recently, anyway. Over the past several months, Tisdale has started appearing in conversations involving mining companies, aluminum manufacturers, investment funds, and trade analysts who have no particular reason to be paying attention to a town this size in a province that most of the world associates with wheat and potash. The reason it keeps coming up is buried underneath it, a discovery that, if even a fraction of the early projections hold, could completely reshape who controls the aluminum supply chains that every major industrial economy on Earth depends on. The discovery belongs to a company called Canadian Energy Metals, and the project is called Thor. The name turns out to be appropriate because the scale of what the company described in its preliminary assessments stopped sounding like a conventional mining announcement almost immediately. Billions of tons of alumina-bearing material alongside critical minerals including scandium and vanadium. Numbers large enough that industry analysts who encounter mining announcements regularly began treating this one differently, not as another deposit competing for capital in an established market, but as a potential structural realignment of where North America gets its aluminum for the next century. To understand why that framing matters, you need to understand what aluminum has become in the current industrial environment. This is no longer simply a metal for soda cans and aircraft fuselages. Aluminum is embedded in every major transition technology that Western governments and manufacturers are betting their industrial futures on: electric vehicle bodies and battery casings, aerospace structures where weight reduction translates directly to efficiency, defense systems across every branch of military procurement, renewable energy infrastructure, the towers, the grid components, the transmission lines, and the massive power grid expansion that electrification of transportation and industry requires. The world needs more aluminum than current supply chains can reliably and cleanly deliver. That gap is not closing on its own. The material found near Tisdale is what started changing the conversation from interesting to strategic. Traditional aluminum production begins with bauxite, a red tropical ore mined predominantly in countries that are geographically remote from North American manufacturing, processed through an energy-intensive method that generates significant carbon emissions and toxic waste in the form of red mud slurry, requiring permanent containment. The Saskatchewan discovery appears structurally different. The alumina-bearing material sits in black shale formations relatively close to the surface. And Canadian Energy Metals believes it may be processable with significantly lower environmental impact than conventional bauxite-based methods. That environmental profile is what triggered the phrase that started circulating through the industry press: green aluminum. It sounds like marketing language, but the commercial logic behind it is real and growing. Automakers across Europe and North America are operating under regulatory and investor pressure to demonstrate lower carbon supply chains. Governments are attaching sustainability requirements to procurement contracts for defense and infrastructure. Manufacturers in industries ranging from aerospace to consumer electronics are responding to customer expectations about the carbon footprint of their production processes. A large, stable, low-emission source of aluminum inside a politically reliable country is not just commercially attractive, it is the kind of strategic asset that procurement decisions are being restructured around globally right now. Canada's existing aluminum industry already benefits from one of the lowest carbon footprints in global aluminum production because of the country's extensive reliance on hydroelectric power for smelting. That baseline advantage compounds the environmental credentials of the Tisdale discovery because the same clean power infrastructure that makes existing Canadian aluminum production low carbon would be available for processing material from the Thor project. The combination lower emission ore processing method, applied to material produced under a hydroelectric power grid, produces an environmental profile that no bauxite-based operation anywhere in the world can currently match at scale. Then, industry experts started raising the question that changes the story from geological to geopolitical. This project is too large for Canadian Energy Metals to develop alone. When a discovery reaches the scale being described in the preliminary assessments for Project Thor, it enters a different category of industrial asset, one that attracts global mining corporations, sovereign wealth funds, manufacturing giants, and governments, each of whom has a strategic reason to want either access to the resource or influence over how it is developed. Once those players enter the picture, the story stops being about geology. It becomes about control. The timing of the discovery against the backdrop of the current Canada-US trade conflict is what gives it its specific geopolitical weight. The United States recently restored and expanded tariffs on Canadian aluminum imports, a decision that created significant disruption inside one of the most integrated industrial relationships in North American manufacturing history. Canadian aluminum producers began shifting export volumes toward Europe and Asian markets. As American buyers faced the tariff-inflated pricing, American manufacturers who had built supply chains around Canadian aluminum faced cost increases and sourcing uncertainty simultaneously. That disruption was already in progress when Project Thor started attracting serious attention. The asymmetry this creates for the bilateral negotiation is significant. Washington applied tariffs to Canadian aluminum on the assumption that Canada had limited alternatives and would eventually accept whatever terms the American market dictated because the American market was absorbing the overwhelming majority of Canadian aluminum exports. The Tisdale discovery introduces a different variable into that calculation. If the project develops at anything approaching its projected scale, Canada's position as an aluminum supplier is not constrained by existing production capacity. It is expandable in ways that could make Canada one of the most important long-term aluminum sources in the world, rather than a mid-sized supplier dependent on American market access. The infrastructure situation amplifies this. Most large mineral discoveries in Canada and globally face a specific practical barrier that prevents them from developing at the speed and scale that geology would otherwise permit. They are located in regions with no transportation access and no power supply. Moving ore from a remote deposit to processing facilities and moving processed material from those facilities to manufacturing customers is what converts a geological asset into an economic industry. The Thor project sits near existing major rail lines. Both CN and CPKC corridors run across the property and near existing energy transmission infrastructure. That means the logistics pathway from discovery to commercial production does not require building the transportation and power infrastructure from scratch. It accelerates the timeline from preliminary assessment to operational production in ways that comparably sized remote deposits simply cannot match.